Hey, it's your old pal RP from ASNA. In this video, we're going to take a look at extending ASNA Visual RPG programs with C#. Now, C#'s an interesting language. It's case sensitive, it's got the curly braces, and it's in many ways similar to AVR, but in many ways it's not. If you've not taken the time to learn C#, I encourage you to do so. It'll make you a better AVR programmer. And learning a little C# helps translate examples, and it's just a good skill to have in your kit bag. And as you'll see here in just a moment, it's really good for little plug-in places for to fill some cracks in your AVR applications. When we first started doing ASNA Visual RPG for .NET, what now, 17, 18 years ago? Our intent then was to keep AVR parallel with VB and C#, to always be able to do with AVR what VB and C# could do. And along about .NET 4, give or take, that proved not possible. We just couldn't keep up. They were moving too fast. And then it also occurred to us that it was sort of silly to try to make AVR do everything that VB and C# did, because AVR has such great interoperability with VB and C#. So there are some things you can do in VB and C# that you can't do in AVR. And we're going to take a look at how to kind of plug that gap here just a little bit. Now, the example that we're going to use, let me pull something up here on my screen. The example that we're going to use is using asynchronous programming techniques in C# with AVR. Now, let's be very clear that this is not teaching how to use asynchronous programming techniques. And it's challenging. There's lots going on with asynchronous programming techniques. About .NET 5 time, .NET 4, 4.5, somewhere in there, Microsoft introduced a sort of a recrafted asynchronous programming model. Up until that point, it was quite challenging to write asynchronous programs. And it still is, but they've added lots of syntactical sugar to C# to make it much easier. They've added async and await keywords, and they've added a task object, which makes it easier and better. Still challenging, though. So I encourage you to read about these asynchronous programming techniques using these links, and there's some C# tutorial links as well. And also note that you can use these techniques with your ASP.NET web form applications as well. But ASP.NET has sort of its own async engine, so there's some special case things you need to do. Now, that said, as you'll see with this application, to get up and running with this, it's not very hard. To get sophisticated with it that's where the challenge comes in, and that's where you'll need to study a little bit. And so maybe I'm picking the wrong example. Maybe I should have done something else, but this seems like a good one, and we had some tech support questions about it lately from 2 or 3 different folks, so I thought I would cover it here. Even if you don't use async and await, even if you don't need async and await, if you need anything else C# offers, the same concepts we're going to see here apply. So let's get started here. Let's start an AVR console application. New project. I'm using AVR 15 with Visual Studio 2017 because that's the virtual machine I got running right now. And these techniques would work probably back to at least AVR 12, I think. I don't know that they'd go back much farther than that. So we're going to do a console application. If you've never written a console application, they're not hard to do, and they're quite useful. We use them to recreate bugs all the time. Async with AVR. That's what I'm going to name that project. So with a console application, let's just throw in a couple lines of code. Then I'm going to copy and paste a few things. I'm going to make, this is how I generally start a console application. Let's make that font a little bit bigger. And then console dot read key. So we'll run this little console application, and you'll see that its output, as with any console application, is a DOS box, press any key to continue. Now you see that right there like that. So what we want to do here initially is we want to have an AVR class library that's got some logic that we're going to use in this program. And then we're going to see how to hook up that logic asynchronously with the help of C#. So what I'm going to do here in my console application, and the solution that owns that console application, I'm going to add another class library for my AVR logic pieces. So I'm going to say add new project. I've right-clicked on the solution. And let me see if something's hooked up and working here. Yeah, that's working. You know, I need to turn on something else too. Let me turn that on. That'll help too. So I'm going to right-click the solution and say, right-click the solution and say, add new project, Visual RPG, and this time it's going to be a class library, AVR. This code will be available on GitHub. I'll show you that URL. It's github.com/ASNA. I don't have to show it anywhere. github.com/ASNA, and you'll find this code there. And then let's copy and paste something into here. Let's copy this right here into here. So this is a class library. And it's not doing much. It has three pretend-like functions, F1, F2, and F3. They're identical except for the amount of time they sleep. And these are stand-ins for AVR doing some kind of logic. Think of it as up here, this one is going to take 5 seconds, this one's going to take 17, this one's going to take 8 seconds. So you could have declared disk files, you could have all kinds of stuff in here doing all kinds of logic. As it's written, you couldn't have any user interface stuff in there. This would all happen on its own thread outside of the UI layer. That's another challenge of asynchronous programming. But you'll see here in a moment how we'll be able to use C# to execute these three routines concurrently on different threads. Now, let's go back to, let's do a couple things. I want to make this guy, I want to change the name of that library there to, that file there to logic functions, just for the semantics of it all. And I want to change this guy's name to program. That's, oops, not that guy, this guy. Okay. So we've got logic functions here. Oh, I just did that completely backwards. I just did that completely backwards. Hang on, let's fix that. This is the program, VR. This is the logic function. Okay, so there's our program. Now it's not going to do anything yet, and we're going to have it call this. Now, the first thing I'm going to do in my AVR console application is set a reference to our logic. Now there's two ways to set references. One is to go out, find a DLL, and set a reference that way. And that'll generally do a copy local and pull that DLL in. And that's a good way to do it if you have the class library that you want to use created and ready to go. Well, we don't. So what I like to use when I'm creating a class library, often with a console application to kind of test it, I like to use a project reference. So what we'll do here is we'll go into our console project, and I'm going to say add a reference. And then instead of browsing for a DLL, I'm going to say what projects, and I'm going to say I want you to reference the AVR logic project. And that is a project reference that'll pull him in and let our console application use the logic in our class library. So then what we'll do is we'll come over to here. And we're going to put 3 declarations in our console application. So what this is going to do is, notice here in our logic, it's got a namespace of AVR logic and logic functions. So if we come into here and say logic functions, AVR logic, and then see this black text? Well, that's because I'm using a dark theme, and then that kind of messes things up. I've never been able to fix this, but there's a kind of an annoying workaround. I'm going to go Tools, Options, Colors, Fonts and Colors. Where's Fonts and Colors? Right there. And all I got to do is that far and click OK. And then it shows up as white. So what I'm doing here is I'm creating an instance, declaring an instance of this logic functions thing in our console application. Now I'm also going to use the stopwatch. Now this is a pretty handy object. It's kind of a in passing kind of thing. So if you declare an instance to, if you set a using statement to system.diagnostics, that'll make the stopwatch object available to you, which will let you time things to the millisecond. And so what that lets us do is, let's paste some more code into here. So what that lets us do is do this much. Now this is all the code we need right now to see the AVR. So we declare an instance of our logic functions class, we nude it. We declare an instance of that stopwatch that lives up in system.diagnostics. And then we declare a milliseconds integer. You'll see that in action here in just a minute. We do a console write line and say, start your synchronous test. We start the stopwatch. Then we run LF, that's the instance name, F1, F2, and F3, passing the word sync, so we can tell which is which here in a minute. Then we stop the stopwatch. We capture from it the elapsed milliseconds, and then we do a write line to the console that tells us how many milliseconds. And so the whole thing right here together conspires to do this, if we're living right. The F1 has been called. It ended. F2 has been called. It's 17 seconds long, and it seems like it takes forever in a context like this. So it's running. And you'll notice that F1 starts and stops. F2 starts and stops. F3 starts and stops. They're running separately in a serial fashion, one after the other. All told, it took 30,000 milliseconds. And we can see that that's about right because here we've got 17 plus 5 is 22 plus 8 is 30,000 milliseconds. So just a few more milliseconds to glue it all together for the calls. This takes 30 milliseconds to run. Now, that's that. Now let's say, but I really would like to run these things concurrently. I want to run F1, F2, and F3 concurrently. Well, in AVR, technically speaking, you could, because you could wire up the threading in the old .NET style. I don't recommend it because it's quite challenging and it's very easy to introduce really bizarre conditions in threading, and it can become a nightmare. Threading is almost like regular expressions. Have you ever heard the old programming saw that says, I had a program, so I tried to solve it with regular expressions. Now I have two problems. That same joke applies to multiple threaded applications, asynchronous applications. I had a problem, but it fans out. I had a problem. I tried to solve it with asynchronous operations, and now I've got multiple problems. So you've got to be really careful with this stuff. Now, let's run these three things asynchronously from AVR with C#'s help. So we're going to add another project to our solution. Add project. And we're going to do, we're going to come down to other languages and say C# class library. And here we're going to call it async, SYNC helper. So we've got our class stubbed in the C# project. Let's change its class name to Logic Runner, and correspondingly, let's change its single source file to logic runner. Generally, it's good to keep the source member the same name as the class. Whoops. Now let's add a subroutine. Now in C#, that's how we would stub in a subroutine. C# formally doesn't have the concept of a subroutine, but if a function returns void, it behaves like a subroutine does in AVR. Let's also add an argument, a message argument that is a string. The type comes first in C#, and then we're going to say console.writeLine MSG. And in C#, it is case sensitive, so if I did that, it won't compile. If we try to compile this guy, he's going to say MSG does not occur in the current context. MSG does not occur in the current context. So that case sensitivity is something you need to get used to. Many of the semantics of C# are very similar to those of JavaScript. So if you're a JavaScript coder, C# will make sense to you probably pretty quickly. Now, let's see if that compiles. And it does. Okay, so let's do this. Let's push him over to the right. New vertical group. And let's go to our program. And let's declare an instance of this AVR, of this C# class that we got here. Oh, we didn't set a reference. So let's go back to the Solution Explorer. And in our console application, I'm going to say add a reference to the, whoops, backwards here. Where am I? Yeah. Add a reference to the async helper and to the AVR logic. Click OK. And now we've got a reference to this C# guy. Now we're going to say declare field LR logic runner type async helper. And then we get IntelliSense that says logic runner, this class. Now at this point, AVR doesn't know and it doesn't care that this class was written in C#. It doesn't care. And we can say, whoops, that says, oh yeah, logic runner, that's fine. Logic runner dot show message. We're getting IntelliSense. Hello, C#. Welcome to AVR. And now if we run this program, I got ready to put a semicolon there and it doesn't need it on this side. So you got to be doing some brain shifts back and forth when you're doing this kind of coding. We'll press F5 and I think that's going to run okay. Hello, C#. Welcome to AVR. And then this runs like it did and it'll take 30 milliseconds. And we're not patient enough to wait for that. So there we've achieved interoperability between VB and C# very effectively. Now we've got project references set. So when we deploy this, you want to have, just like you would if you were using regular references, we'd want to have that DLL in that same folder as that AVR executable so that it can find itself at runtime. Now this is not the class we want, the code we want in that C# class. So let's go back to it. Let's get this guy out of here. And I'm going to just copy some code, not very much code. It's interesting code. Well, let me just put the whole thing in there. Let's copy some code into there. Now, what we need to do here, having pasted that code, notice we get red squigglies. So before we explain the rest of the code, let's fix this because the C# class is declaring an instance of our AVR logic, so he needs a reference. So I'm going to say add reference. Now I'm in the C# class to AVR logic, and that will resolve that. Now let's come down to here for a second. And now we're getting into C#, major C# differences. C# has the async keyword. These are asynchronous methods. Kind of like we saw void a minute ago, these are asynchronous. Now, by default, they're private. I could stick the word public out here, but I don't need to because I'm going to call these from inside here. Now, it also has some other interesting syntactical sugar. This is pretty challenging if you've never seen it before. It's not that hard, really, but it is. I understand why it's kind of hard to get your head around. That's what's known as a lambda, or an inline function. Now, the way to wrap your head around that is if we're going to make something up. You can't really do this, but let's pretend like you could. See if this helps make that make sense. If we said task, run, and in C#, in JavaScript, you can declare a variable that is of a function. So let's pretend like we could say function now you can't do this. I'm just making this up. But what happens here with this stuff is this is effectively that. This is what's called the goes into operator. And it's saying this argument list goes into whatever this function is declared here, which would be, that line is equal to that line. Now, they've got some syntactical sugar here because this is just a one-line function. And being a one-line function, it doesn't need curly braces. But we could put curly braces there. And that would still compile, and that is still, what's going on here? That shouldn't be there. Oh, but that should be there. That should not be there. Whoa, hold on, hold on. Oh, and now we got to close it. It gets pretty, and I think, yeah, it gets kind of hairy quickly. If our lambda function had more than one line, we could put the curly braces and add as many more lines as we needed in our function. And so it would be parameter list goes into this function body, which is what we see here. Parameter list goes into this function body. So this lambda is just a shorthand for a function. But then they further refined it in C#, well, and JavaScript as well, because they said, hey, look, if your function only has one line of code, dispatch those curly braces and just write it like that. Let's see here. We need to take that off. We need to come up to here and say, and get this guy out of here. Oops. So now, what am I? Oh, and I'm missing that guy on that side of that. So this is a lambda. And again, you're going to have to study lambdas if you're going to use this async stuff, because it's all over the place in asynchronous stuff. AVR does not support the lambda syntax. So each one of these is basically using the task object in the system.threading.tasks to create an asynchronous task. And then the goodie, or the interesting part, is our asynchronous task is going to be our AVR logic. We got an instance of our AVR logic up here, and we can call F1, and we're passing the word async. Here's we're calling F2, and we're calling F3. So even though we've got this async wrapper around that stuff, it's still the same AVR logic. So this could be any AVR logic that we've wrapped up in these things. Then we've got a method up here called run, which uses the task object and its static waitAll method, which says waitAll and execute those three functions for me in parallel on different threads. And this is a pretty flexible function. It can have a pretty flexible method. It can have a bunch of functions hanging off the end of it out there. So you can execute as many as you need. So it is sort of type sensitive in that you would need one of these special case wrappers anytime you want to have parallel execution of AVR functions. So now we've got this all set up. If you don't understand this, don't worry too much about it because you need to study async and await a little bit. There's all kinds of things you can do with this, but this is one of them. This is kind of an interesting example. So now that we've got all that, let's see if that compiles. Let's make sure that we're doing that well. Okay, so now we've got our logic runner. So now we're going to use this guy to dispatch those classes. So let's add something to this code here. This is our console application. And what I'm going to add to him is a couple of things. First of all, well, I've already added, let's see. I've already added the declaration, so that's a good thing. I need that up there. Take this show message out. We took him out. And then down here, we're going to add a little more code. So give ourselves a blank line on the screen. Say that we're starting the asynchronous tests. Reset our stopwatch. Restart the stopwatch. And then call, this should say LR. And that should have IntelliSense on it as well. Let's see, LR.run, yep, right there. And so what's happening here is reset the stopwatch, take him back to 0. Start the stopwatch, call LR run, which is this method right here, the logic runner's run method, and then stop the stopwatch, get the milliseconds, and show him what the milliseconds is. So let's watch this. Let's watch this run. Remember that we got 5, 17, and 8 seconds on each one of those. On L1, L2, and L3. 5, 17, and 8. So if we run it, whoops, invalid character somewhere. Oh, I'm in AVR. No semicolons in AVR. Press F5. It starts the synchronous test. Started F1. Now it's starting F2. This is the one that takes 17 seconds. Not 17. How much was it? Yeah, that's right. So it ended. Now F3 started. So they run serial, one after the other. Going to take a little better than 30,000 milliseconds. Now look what happened here. F1, F2, and F3 all got started. F1 ended. Now guess who ends next? F3 ended. It only had 8 seconds or 8,000 milliseconds. And finally, F2 ends. Now when we ran those, it took almost half the time. And in fact, what you basically got with the async operation is you got to run F1 and F3 for free. It has to take 17, it absolutely can't go less than 17,000 milliseconds because that's how long it takes to run F2. But here we can see that it was able to execute F1 and F3 in the time it took it to run F2, and it did so asynchronously. So there we can see a couple of things, that we can extend AVR with C# and do so pretty painlessly. Now, certainly the pain increases if you don't know anything about C#, but it's not hard to learn a little C# and use C# to extend AVR. Another place, and this is the example that I considered showing, is that AVR is not able to execute Windows APIs, but C# is. So another very common reason to extend AVR with C# is to use Windows APIs. So for example, there's good Windows APIs for, let's say you want to move a window around, but rather than clicking the title bar, you want to click anywhere in the window. There's Windows APIs let you do that kind of stuff. And C# can harness those for you and let AVR use it. But given that we'd had several questions in tech support about async and await, I thought I would do that with this example here. So that's async and await and the task object in C#, but harnessed by AVR so that it's all done up inside an AVR application. If you go to github.com/ASNA, you will see this example posted there. It'll be the top one on the list or near so. And you can download the code. And then let me end with showing you these guys again. Here's these links, C# tutorial. And then if you're going to pursue async and await, you need to study it. This is not trivial stuff. As you can tell by the minimal C# we had to write to harness it, it's pretty streamlined, but there's still gotchas and unusual things await. So you've got to really pay attention to the details. But they're very well documented, and if you want to dip your foot into asynchronous programming, they will let you do that. Thank you very much for watching. We appreciate it. Whoops, I'm back. I forgot something for the video that I just ended. I forgot to show you the debugging experience between AVR and C# because it's very effective. So here we have our AVR console application, and this is where he's making a call to the run method in our C# class. So I'm going to put a breakpoint on that run. I'm going to press F5 and run the application. And we're going to have to wait the 30 seconds for it to finish to get through the first part. So F1 has started. F1 doesn't take very long. When we get to F2, it seems like it takes forever when you're sitting here watching it. Okay, F3. And it's almost done. And it'll hit our breakpoint. Now, watch what happens when I press F11. This is the, you can't see my hand. This is the C#. This is the AVR. I'm going to press F11. Boom. We come over here into our C#. Now, we've got asynchronous stuff going on, so there's not much debugging to be done over there. But if we had a bunch of C# code, we could F through F11, press F5, it'd come back to the AVR if you had another breakpoint. The point is the debugging experience is superb between AVR and C#, especially with project references where it's easy to find the source for the various projects. So I just wanted to inject that real quick. Thank you very much.